Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh, and good morning to everyone. So, as you see, my name is Hikma Shabani, doctor. So today we are going to learn about electromagnetic theory, but it will be about the briefing introduction. So as you see here, the course outlines will be given in the course plan with all the details. And the method of evaluation here, so we'll be having like a final exam will be 50%, and the test will take 30%, and the assignment will take 20%. So without delaying, now we go directly to our chapter 1, which is a brief introduction to EMT, electromagnetic theory. So the outline for this first topic, we have we're going to learn what is electromagnetics. After that, we are going to see why do we need to learn this subject, electromagnetics. And at the end, we are going to see a few examples of electromagnetics. So now, our subtopic, what is electromagnetics? Actually, electromagnetics is the study of the effects of charges at rest and the charges in motion. So some special cases of electromagnetics here we can highlight. We have electrostatics, so which is let's say charges at rest and no movement, and the magnetostatics, charges in steady motion like a DC direct current, which is a steady motion, the movement that does not variate, which is a constant motion. And finally, we have electromagnetic waves, which are the waves excited by charges in time varying motion. Yeah. So here we see two devices communicating. We have the base station and the receiver here. As you see, we have waves in between these two devices. So we see transmitter, which can be the base station, and the receiver, which can be your mobile phone. So these two devices are connected by what is called the field. The field are those waves. So it is defined that when an event in one place, in our case here, with from the base station, has an effect on something at a different location. In this case, what is at different location is, let's say, your mobile phone. So when this base station is affecting, is making some impact at your phone, so we said that the event is being connected by a field. This impact, this effect of the base station to your mobile phone is being connected by the what is called a field. So a field is a spatial distribution of a quantity. Is a quantity which is distributed in space. So in general, it can be either a scalar or a vector in nature. These quantities. Here we are going to see few definitions here, like a scalar. A scalar is a quantity that having only an amplitude. For instance, you can say the voltage, current, charge, energy, temperature is just one amplitude only. For a vector, this one is a quantity that having direction and amplitude. We have two components. We have one is for the direction and another one amplitude. So for example, here I can say velocity, acceleration, force, and so on. So electric and the magnetic fields. So are the vectors fields with three spatial components, this electric and magnetic fields, or are the vectors, meaning they do have amplitude and direction, but in three spatial components, meaning x, y, and z, the axis. So they vary as a function of position in 3D space, three-dimension space, as well as time, as I mentioned above, in the X, Y, and the Z direction or Z axis. So this field are governed by partial differential equations derived from Maxwell's equations. Here we can highlight that Maxwell equations play a fundamental role in the electromagnetic fields. So vector field quantities here in electromagnetic, we have what is called electric quantity and the magnetic quantity. So in the electric quantity, we have what is called electric field intensity, which is defined as E, the capital E. So the unit of it is a volt per meter, volts per meter, with electric flux density represented by a capital letter D. So unit will be coulombs per square meter, and with a magnetic quantity. This magnetic quantity we have also two fields. Magnetic field intensity symbolized by capital letter hash. Unit will be ampere per meter. And the magnetic flux density characterized by capital letter B. Unit will be Tesla or Weber per square meters. Some universal constant in electromagnetic. Here we have a velocity, which is an electromagnetic wave in free space. Example given here for free space is C, which is approximately this value, 3 times 10 power of 8 meter per second. So velocity, the speed of electromagnetic waves in free space. We have a permeability in free space is mu0 or mu-o, which is given by this value in Henry per meter. We have a permittivity of free space epsilon naught or epsilon 0, which is given by this value, and we have the intrinsic impedance of free space, which is given by this number 100 by tau. We have a universal constant in electromagnetic. So relationship involving universal constants. These are the relationships. We have C as the velocity of waves in free space given by this 1 over square root of mu naught times epsilon naught, and n naught, and so on. We have in free space, we have a B, which is magnetic flux density, and a D, which is electric flux density given by the value, by the terms on the right side. Okay. So now, why do we need to learn electromagnetics? So the reason is behind, normally is with the increase of electromagnetic frequency spectrum. So with the use of what we call this wireless devices, we need to get more and more electromagnetic frequency spectrum. Now with the 5G generation, with the IoT, Internet of Things, so this one showing that the increase is very sensitive. The increased use of electromagnetic frequency is very sensitive and very fast. So now for this one, so it demands for engineers with practical working knowledge in the area of electromagnetics. That is why we need to learn this electromagnetics, because of this use of electromagnetic frequency spectrum. So we need some engineers with that knowledge. That's why. So second reason is the electromagnetics technical specialty prepares future engineers for employment in industry and in the area of, for example, radar. Second, with antennas, if some pictures here, with the fiber optics, all this require the knowledge in the area of electromagnetics. We have a high frequency circuit, electromagnetic compatibility, so microwave communications. So all this require that knowledge. Without the knowledge of the electromagnetics waves, so difficult to be involved in these things. So we need engineers with this knowledge. That is why we need to learn this gradually, no stop. So now we have a few examples of electromagnetics waves. Yeah, I can see here the rainbow is also one example of electromagnetics waves. We have other examples here, as you can see, and the pictures here. So many electromagnetic waves and so on. So in the what you call the transmission lines and the different what you call antennas, all this in the skies, you can see. So electromagnetic waves can hit anywhere, any places in the transmission lines, you see. So that is all for today as a brief introduction of electromagnetic waves. So inshallah, if any question, this is time to ask questions. So thank you very much.